assume that for this problem, it wasn't given that we have 1,000 turns for N1 and 10 turns for N2. This is known as a Tesla coil. It's a high voltage generator that is used in museums. And we know that the inductance L can be given in terms of N2, the magnetic flux through the second solenoid over the current in the first solenoid. And we know that the magnetic field in the first is U0 N1 I1, which is the same as mu0 capital N1 I1 over L, which is the length of the solenoid. So the inductance L is going to equal N2. Instead of the magnetic flux in the second solenoid, we can say that that is going to be B1 times the area all over the current. And so we can say that this is N2 U0 N1 I1 over I1 times little l all times A, which is the same as mu0 A N1 N2 excuse me, over little l, because the i's will cancel out. And so if we find the inductance and we plug in our values, U0 is 4 pi times 10 to the negative 7 Weber per amp meter. The area is 1 times 10 to the minus 3 meters squared. N1 is 1,000, N2 is 10, all over 0.50 meters. Again, if we're not given that, let's assume little l is 0.5 meters. And this will give us 25 times 10 to the minus 6 henries, which is the same as 25 microhenries. And now for part A, the magnetic flux through the solenoid is the inductance times the second current over N1. So this is 25 times 10 to the minus 6 henries times the current at 3 microseconds is going to be 2.0 times 10 to the 6 amp per second times 3 microseconds all over N1, which is 6,000, and that gives us 1.5 times 10 to the minus 7th Webers. And now for part B, the induced EMF is minus the inductance times the derivative of the second current, sorry. So this is minus 25 times 10 to the minus 6 henries. The derivative of the second would be the 2.0 times 10 to the 6th amp per second. The derivative of t with respect to t is 1, and that gives us minus 50 volts.